In this video, we'll review the exercises we did in class today. You can use this to prepare for the quiz on Wednesday. It involves only working with stocks. We're not working with any risk-free asset, which means we don't need to worry about Sharpe ratios, tangent points, or capital allocation lines. In order to optimize a portfolio of stocks, the first step we'll always do is calculate a periodic return. And in this course, we're doing it this way. There are other ways to do it. For those returns, we'll calculate the average, which becomes the expected return for a given stock. And then we'll calculate the excess return, which is, for any period, that return minus the expected return. That can be used, it can be averaged, and then we take the square root of that average to get the standard deviation for the stock. It can be used mathematically to calculate variance and covariance matrix, and that's what we're going to use it for in these videos. The formula for the variance covariance matrix uses arrays, and with any array formula, we need to remember to hit Control-Shift-Enter to enter the array formulas and make sure that all the cells where we want the answers to show up are selected before we type the formula. Then the standard deviation of returns of that portfolio involves another array formula, and it involves weights. We have to assume some weights that we can then come back and change as we optimize. The expected return of the portfolio is one last array formula. So let's get started. In this exercise, we're a wealth advisor with a client who would like to put $1,000 into 2 stocks in whatever combination minimizes the risk. So we'll copy our headers over and begin calculating returns. Can't calculate a return for the first period because we need the current period over the previous period minus 1. But we can copy that formula for all stocks and all periods. And in keeping with our color scheme from before, we'll go ahead and color code that for clarity. Then we want to calculate the expected return for each stock. H simply the average of the returns for each stock. Copy paste. And since these are all returns in terms of percent, we'll format them as a percent with a decimal place. Next, we calculate excess returns. In keeping with the formatting, I think we were coloring that blue. An excess return is simply any given return minus the expected return for that stock. And we'll put a $sign on the row so that we can copy it for both stocks. Let's come down and check a random location. Good. Now we need to calculate a variance covariance matrix. Copy the stocks across the top and then also down the side. Alt HVT for paste special, transpose. Then to enter the variance covariance matrix, remember to select all 4 cells. And to type this formula, I just hit tab and then TR tab and then choose the excess returns. Close out the transpose function and put the comma in to separate the inputs for the matrix multiply function. And select the excess returns again. Close out the matrix multiply function. Divide that by the number of rows. As we discussed in class, I think it's best to go ahead and just get the rows of the entire excess returns matrix. It's not necessary. You could have chosen any column. All we need is the number of items in that list. But this way we have the same reference. It shows up blue all 3 times. If we had made an error that 3rd time and accidentally left a row off, it would be very glaring that that looks different than it does over here. And that's why I like to choose the rows of the entire excess returns matrix. And then to enter this, we've got all 4 cells highlighted. We'll Control-Shift-Enter, and all 4 cells get populated. Let's just say that we forgot to do that, though. Let me cut that formula and delete it. Let's say we came in here and went through that big long formula, got it the way we wanted, hit Control-Shift-Enter, and realized we had left out 3 cells. Don't retype that formula. Simply highlight all 4 cells, hit F2, and then hit Control-Shift-Enter. I think we were coloring that green before. So we've got our variance covariance matrix. The next step is to get the standard deviation of returns of a portfolio. Well, a portfolio has a weight of stock 1 and a weight of stock 2. And we can enter them as values and then later come back and put a constraint in solver that says the sum of those values is equal to 1. Or we could have simply said this is 1 minus this and not had to have that constraint in our solver, and this would be the only cell that we changed. That works fine for 2 stocks, but since we're going to be doing this for more than 2 stocks, I like to just enter these as values, format them to make it clear that they're values that can change, and then make sure that we have a cell that can check that we sum to 100%. Next, we want the risk, Alt-IS to insert a symbol for risk, and it's the standard deviation of the portfolio, so we'll put sigma p. I'm going to hit F2, shift left arrow, hit F2, shift left arrow, and then Control 1 to pull up the font and make it a subscript. Don't have to do that, but it looks nice. Next, we want the expected return of the portfolio, E of R sub P. Same thing here, F2, select the P, Control 1, Alt B to get the subscript, and then return for enter. Now let's go ahead and calculate the risk of this portfolio using the standard deviation of returns formula. Equals SQ tab, MM tab, MM tab, select the weights, comma, covariance matrix, close out that matrix multiplication, and then enter the term for the second matrix multiplication, which is the transpose of the weights. Out all 3 parentheses. I like to go ahead and type them to make sure the last one's black. Otherwise, it means I've made a mistake, and Excel may try to fix it for me, and I may not like how it fixes it. So I like to close it out on an involved formula like this. Control-Shift-Enter to get our answer. It's a percentage, so we can format it as such. Come over to the return and use this final formula down here, where we take the matrix multiplication of the weights and the transpose of the returns. Close it out, Control-Shift-Enter, and now we know the risk and return of our made-up 4060 portfolio. But what we want to know is what portfolio would minimize the risk. So we would need to use Solver by going to Data and Solver. If you don't have Solver, go to File, Options, Add-ins. Make sure this says Excel Add-ins and then choose Go so that you can select the Solver add-in. So we'll use Solver to minimize the risk. So let's reset everything. And our objective is the risk. We want to minimize it by changing the weights, subject to the constraint that the sum of the weights is equal to 100%. and then we can solve. So a 72-28 split between stock 1 and stock 2 gives us the minimum risk portfolio. However, the question asks us to find the dollar amounts to invest into each stock. So don't lose any points on this. If the portfolio is $1,000, then dollar investment then the dollar investment is 1,000 times the weight. Copy it, and we know how many dollars now go into each stock. Please don't forget that last part. Moving on to the next problem. In this problem, we're a wealth advisor whose client also has $1,000 to invest, this time in 3 stocks. They want to maximize their returns without exceeding a risk of 14% standard deviation of annual returns. Kind of a picky client, but let's do it. Let's copy the adjusted close, call it returns, calculate the returns, copy, take the average, call it expected returns, Alt-HAR to align that right. Let's format these as percentages and color them yellow. Now let's take our excess returns as any given return minus the expected return. Copy it, check a random cell, looks good. I'll color it. And now we're ready to calculate our variance, covariance matrix. So we need the 3 stocks, paste transpose, select all 9 cells and begin to type our formula for the variance covariance matrix. tab, tr tab, choose the excess returns, choose them again, and again. Control Shift Enter. We have a variance covariance matrix. Now we're ready to create a portfolio that we can then optimize to meet the objectives. This time we have 3 stocks. Let's just guess 30, 30, 40. Make sure they sum to 100. See what their risk is. And their return. And the risk is this formula that starts with square root. Looking at the weights, which I forgot to color, and the variance covariance matrix, and the transpose of the weights. Control Shift Enter, %. Format that as an input so it's clear when we use solver what numbers we want to change. And then we can use the last formula, the matrix multiply the weights with the transpose of the returns. Control Shift Enter. Now let's optimize. We don't want to exceed 14%, but we want to get standard deviation, but we want to get the highest return that we can. So interesting discussion in class. It may be tempting to want to optimize on the standard deviation, but we wouldn't then later be able to maximize the return. So let's start with return. And maximize it by changing the weights while making sure that the total weights equal 100%. And we also want to make sure that the risk is less than or equal to 14%. And I could have typed 0.14. Now we all know that we could set that equal or less than. It's going to get us to the same answer. This problem stated as without exceeding, so probably more appropriate to say less than or equal. So we didn't exceed our 14% standard deviation. The return of the portfolio is 11.1. So let's answer A and B. So if the portfolio is $1,000, then the dollars in each stock, align that to the right, are going to be the portfolio amount times the weight. That's an output, so we want to make that easy to find when grading. And then part B says, what return can your client expect from this portfolio? Let's make that clear as well. Client can expect return of 11.1%. Probably on the quiz, I'll just say fill in that cell for the output. So this all feels very repetitive. It feels like you're memorizing something for a quiz, and to a large extent you are, but the next problem is an example of how we're going to apply that. Same thing, we're given some stock histories and we'll go through the same calculations we did, but here we're asked a question. You're a CFO redesigning your 401k. You need to choose 3 of these 4 stocks to keep. That means we need to know which one is least important in our portfolio. And the way this problem works is you solve for several different portfolios. There we go. You solve for several different portfolios, 5 in fact, and then we're going to see which stocks are the least important, whether the employees decide to choose any of those 5. If your employee decides to choose a minimum return to optimize their portfolio, you should probably think about getting a different employee. So let's copy that, call it returns, we'll be doing our expected returns. And our return is the current stock price over the previous stock price minus 1. Copy and paste. Let's just check a random one to make sure we got that right. We did. Take the average. Make them percentages. Color them yellow. And now let's do excess returns. We'll make these blue. An excess return is just any given return minus the average return for that stock. Copy and paste. Check some random cell. Looks good. Variance, covariance matrix. Copy, paste. Paste, transpose. Select everything we want to enter, and then we'll use the variance covariance matrix formula. Equals tab, tr tab, excess returns, and again, close it out and divide by the number of rows in the excess returns. Control Shift Enter. We're going to build 5 portfolios. So let's go. We know by now that it starts with sum. It's going to be the sum of the 4 stocks in this case. We know they're going to be formatted as inputs. And let's do 25% in each. And then we'll calculate a risk. And a return. The risk is going to use the standard deviation of returns that begins with square root, SQ tab, 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 weights, variance covariance that I forgot to turn green. Close it out, TR tab. I'll always hit that parentheses after transpose. And weights again. Close it out. It should take 3 times and it turned black. Control Shift Enter. Format it as a %. Now let's do the expected return. Matrix multiply of the weights by the transpose of the returns. Very much rote memory to this point. Control Shift Enter. Percentage. Color. So this is very much just memorizing the steps, getting through that quickly. It's good practice for you in Excel, and it's good for us to talk a lot about how matrix or how array formulas work. But the key problem for the quiz and the exam will be, can we apply this and use it in real life? And so if we want to describe 5 different portfolios, we're told in the problem statement that one is the minimum return. Next is the max return. The next is the min risk. And the next is the min risk for 8% return. And do that one for 10 as well. I'm going to copy this row. Oh, not until I put dollar signs on there. Fix the variance covariance matrix reference. And fix absolute references on the weights. Excuse me, the returns. Control Shift Enter on both. We should be able to copy and paste. We can't paste on top of an array, which is kind of unusual, but we can paste below it. And all these stayed the same, so we must have gotten our absolute references right. Now let's go through and let's optimize each of these portfolios. So using data and solver, we'll reset everything. And the first objective is to just have the return minimized by changing the stocks such that the sum of those weights is equal to 1. So the lowest return we could get is 3.8% by putting 100% into Kellogg, which is the lowest returning stock. It's a good thing to check that all that makes sense. Next one is the max return. And so we'll go to Data Solver. And this time we'll set the return to a maximum by changing the next row of weights. And let's change that constraint to say that the next row is equal to 1. When we solve that, we see that it puts 100% into ExxonMobil to get 12.8% return. 12.8% return is the return of the highest returning stock, which is ExxonMobil. So we're good so far. Now we want to minimize our risk. This is probably what we did in exercise 2. Let's do that one again. Let's set the risk. Oops. The risk is in column T. I want to set that risk to a minimum by changing the third row of weights subject to the constraints that all those weights add up to 1. Next, we want to set the return we want to set the risk to a minimum by changing those weights subject to the constraints that the sum of those weights are equal to 1. And this time we want to add a constraint that says that the return for that portfolio is equal to 8%. I can type in 8% or I can type 0.08. Works the same either way. And we get 8% for a return and a risk that's a little bit higher than we got for a lower return. Makes sense. Finally, we will solve to minimize the risk in the last portfolio by changing those weights subject to the constraint that the sum of those weights is equal to 1. And this is the one I always forget, to change the reference to the return as well as the return. And we get a 10% return with the minimum risk possible. Now the problem asked us to use all 4 stocks to find those weights for the following portfolios. We did that part. Don't forget part B. Part B is the most important part here. Observe the optimized weights and select which stock is least important. So if you're the CFO and you need to drop one of these stocks, you look at AT&T and say, even the people who tried to minimize their return didn't need AT&T. The people who tried to maximize their return or minimize their risk or shoot for a certain return, none of them needed AT&T, but some of them needed all of the stocks. All the stocks were used by some portfolio or other except AT&T. So AT&T is least important stock because it was used in any portfolio. Let's highlight that, format as an output. Good luck on the quiz.